Okay, so here we're going to do some rules today with negative exponents. So, I'm going to go through some problems with you. 2m to the negative second times m to the third. Now, if you notice, even though the 2 doesn't carry over, the base of that power is the same. The m's match. So we're still going to use that same rule where we add the exponent. So if I'm multiplying, I would have 2 times, the coefficient here is 1. 2 times 1 is 2. And m to the negative second and m to the third. With 2 bases, I am going to add those exponents. So that would be negative 2 plus 3. What is negative 2 plus 3? That gives me 1. And do we write a 1 exponent? We don't. We would just say that the answer here is 2m. Okay? So whenever possible, even if you have a negative exponent or a 0 exponent, follow your same rules that you learned before. That's going to happen here too. If I have p to the negative third to the positive third, this time I have how many bases? Only 1. So that rule says that I am going to multiply the exponents. So negative 3 times 3 gives me p to the negative ninth. Now, we cannot leave a negative exponent in our answer. That's the rule with negative exponents. So here's what you need to remember. When you have a negative exponent, that letter goes to the opposite side of the fraction. So what fraction are we talking about here? Well, technically every number is a fraction, correct? I could call that p to the negative ninth over 1. And you notice the p is on the top of the fraction. Well, in order to make this 9 a positive 9, I need to move that p to the bottom side of the fraction. And then I can call it a positive 9. Now, I don't want people to get confused. I am not going to be flipping the whole fraction. The only thing I'm moving is the p to the negative 9. This 1 is still here. We just don't need to write it because we have the variable. When I have nothing left on top, I'm going to put a 1. So I am not done with my answer until all of my exponents are positive. All right? You'll notice on your homework, it says simplify, and then it says your answers should contain only positive exponents. So you have to make sure that all of your exponents end up positive. Okay? So let's look at another one. R to the negative third over 3r to the positive third. Now I have 3 things going on. I have r to the negative third, I have 3, and I have r to the positive third. Now if you notice, do either of those have a negative exponent? No, it's all positive. So those guys get to stay on the bottom. This guy, however, has a negative exponent. And where is he currently? He's on the top. So where does he need to go? Just like the p to the negative ninth, he's got to go to the bottom. That's going to give me another r to the positive third. That exponent becomes positive down there. So instead of just having the 1 r to the third, I now have another r to the third because that guy had to move down. So nothing's left on top. What do I put? I put a 1. So let's see. Can we simplify that bottom any further? Well, r to the third times r to the third. I have 2 bases, and my rule with 2 bases is I am going to add those exponents. So that's what my answer looks like there. Okay. Number 4. 2x to the negative second over x to the negative first. So I have an x on top and an x on the bottom. I could use my subtraction rule, but my subtraction rule is a whole lot easier to do when I'm dealing with positive exponents. So I'm going to move the terms around first to get those positive exponents, then I will use my subtraction rule. So here's my first question. Does this negative 2 apply to that big 2 out in front? No. The only way it would apply there is if I had parentheses in front of my 2 and behind my x before that exponent. Since it doesn't apply to the negative 2, I'm sorry, to the positive 2, the x is the only thing that's got to move. What does that mean for that 2 then? Well, that 2 is going to stay. Doesn't have to move because it doesn't have a negative exponent. The x to the negative second, that guy moves to the bottom, and he now has a positive 2. What about this guy on the bottom? He's got a negative exponent. Well, we haven't had one on the bottom yet, but if I have a negative exponent on the top, just like the top one had to come down, bottom one has to go up. And a positive 1 exponent, I can leave just like that. So, now that I have positive exponents, now I can do my subtraction. I can do the top exponent, which is a 1, minus the bottom exponent. That gives me 2x to the negative 1. Again, I have a negative exponent, so I got to move that x to the negative 1 down to be x to the positive 1 and a 2 on top. Now, if you wanted to skip this and just use the shortcut, you have 2x on top, you have x and x on the bottom. Those x's cancel and you're left with that 2 over x. That's a shorter way of getting there if you recognize what's going on using the long method. Okay? All right, number 5. X to the negative third over 2x squared is my denominator. So, I think there's only one issue here. The 2, there's nothing to reduce it with or simplify it with. The only issue I have is the fact that I have a negative exponent on the top. So if I look at the bottom, everything's positive, so it's going to stay where it's at. This guy's got to move down to the bottom, and it will become a positive 3 exponent. Now, everything is missing from the top. So what do I do if everything's gone from the top? I put a 1 up there. And then I have 1 over 2 x to the what power? I see 2 bases, so I'm going to add them, and 2 plus 3 is 5. So that's what my answer looks like there. Okay, number 6. Going to throw this in there. This is a little bit of a review because this one doesn't actually have a negative exponent. I have r to the second on top, I have r to the third on the bottom. If I look at the 3 out in front, there's nothing to reduce it with, so that 3's just got to stay there. Now what happens if I do r to the second and r to the third? Well, if I do that whole top minus bottom thing, I would have 2 minus 3, correct? Which gives me r to the negative 1. Where do I write r to the negative 1 in order to make it positive? I'm going to have to write it on the bottom. And a 1 exponent we don't write. Again, there's nothing left on top, so I'm going to put a 1, and my answer looks like that. If I'm ever curious about where that r is going to be left, or where that variable is going to be left, think about the fact that you have 2 r's on top and 3 r's on the bottom. I have 3 r. I'm like a pirate. Cross those out. I have nothing left on top. That's the 1, and I have 3 r left on the bottom. That's what's going on there. Okay, all right, number 7, a b to the third over 3 a to the 0 b to the third. So let's look at some things here. I have a 3 on the bottom just like I had up here, and there's nothing up here to reduce it with, so that 3 is going to stay on the bottom. What happens if I have a over a to the 0? Well, a to the 0 is just 1, isn't it? So if I dropped that out and I made it a 1, 3 times 1 is just 3, so it really just disappears from the problem. So my a up here, it's got to stay up there. Got nothing to do with anyone. What happens if I have b to the third over b to the third? Well, if I think about that the long way, that's 3 b's on top, 3 b's on the bottom, everything cancels. B to the third over b to the third is equal to 1. So the only thing I have left is a over 3. Okay, all right, I'm going to do 2 more examples for you. Let me get another piece of paper there. Number 8, v u to the third over negative 2 u to the second v to the negative first. So Let's see what can stay where it's at and what's got to move. So first thing I notice is the number out in front. I have a -2. There's nothing on top to reduce it with. Do I need to move the -2 to the top because it's negative? No. The reason is it's not an exponent. It's only the exponents that can't be negative. Regular numbers, they can be positive or negative. We don't care. The exponents are the only issues. So that -2 stays on the bottom. Now I'm going to go to the letters. This V up here, it has a positive exponent, right? It's an exponent of 1. He stays on top. This U, he's got a positive exponent. He stays on top. This U down here, positive exponent, so he can stay where he's at, which is on the bottom. This V is the only one that's causing trouble. It has a negative exponent, so I'm going to move it to the top, and that will make a +1 exponent. So let's see what we've got now. On the top, V and V, that's going to give me V squared, because again, I have 2 bases, so I'm going to add those 2 exponents. I have U to the 3rd, and then on the bottom, I have -2 U squared. So you can do your subtraction with your U's. You can do the top minus bottom, or you can think of it the long way. You have 3 U's on top, 2 U's on the bottom. That leaves you with 1 left on top. So that's going to give me V squared, 1U, over -2, and no U's left on the bottom because they all canceled out. Okay? All right, last one. This is how I try and make things tricky. I throw in a lot of letters. There's Z to the 2nd over 2Y to the -3rd. I throw in a lot of letters, but all you have to do to make it simple for yourself, just take them 1 letter at a time. So I'm going to start off with the 3 over 2. Can 3 over 2 reduce? Nope, nothing can reduce there. So there's going to be 3 on top. There's going to be a 2 on the bottom. There's nothing I can do about those guys. X to the 2nd, that's a positive exponent. He can stay where he's at, which is on the top. Y to the -1st, that's a problem. Can't stay on the top, got to move to the bottom and become Y to the +1st. Z to the 2nd, that one can stay on the top because we have a positive exponent. On the bottom, I already dealt with the 2. I have Y to the -3rd. That guy's got to move to the top in order to become +3. So, am I done? Almost. I still have Y's to deal with. So if I have 3 Y's on top and 1 Y on the bottom, those 2 cancel and I'm left with Y squared on top. So my final answer here would be 3x squared, Z squared, and then Y squared all over 2. Okay, now you're going to have an opportunity to practice that. Your homework is, where did it go? This worksheet right here, I think I copied it on tan paper because we're out of white paper, sorry. But there's a place for this to be submitted on Google Classroom, so once you finish your homework, submit it on Google Classroom. Remember, it is due by 8 a.m. tomorrow, which is the 14th of August. Happy studying!